Picture this. Right now, at this very moment, there's something massive lurking in the darkness at the edge of our solar system. Something up to 10 times heavier than Earth. Something that's been pulling and twisting the paths of distant worlds like a puppet master in the shadows. And here's the wildest part. We've been looking for it for over 100 years, and we still can't find it. How is that even possible? We can photograph planets circling stars that are dozens of light years away. We can peer back in time to see the first galaxies that flickered to life after the Big Bang. But somehow, a planet-sized object in our own cosmic backyard has managed to stay completely hidden. Until now. Because earlier this year, scientists discovered something buried in 40-year-old telescope data that might finally crack this mystery wide open. Let me take you on a journey to a place so remote that light itself would need more than 8 hours to reach it. We're talking about a region 9 billion kilometers from the Sun, far beyond Neptune's orbit, where the solar system becomes something alien and strange. Out there in the frozen darkness, thousands of icy rocks drift through space, objects we barely understand, called trans-Neptunian objects. The story really begins back in 2003, when Professor Mike Brown and his team at Caltech decided to explore this mysterious realm. They weren't looking for anything in particular, just mapping the outer edges of our cosmic neighborhood. Then they found Sedna. This dwarf planet, smaller than Pluto, was traveling on one of the weirdest orbits anyone had ever seen. Highly elliptical and steeply inclined, like something had grabbed it and thrown it off course. At first, scientists thought maybe Sedna was just an anomaly. Space is full of surprises, right? But then they kept finding more objects with equally bizarre orbits. Some crossed Neptune's path. Others moved backward compared to the 8 planets. Many were tilted at extreme angles. It was like discovering that all the paintings in a museum had been knocked crooked by the same invisible force. There's only one mathematical explanation that makes sense of all these twisted orbits. Something called the Lidov-Kozai mechanism. Essentially, it's a gravitational dance involving 3 partners: the Sun, these distant objects, and something else. If you're as obsessed with space mysteries as I am, you're going to want to hit that subscribe button right now, because what I'm about to share with you could rewrite everything we thought we knew about our solar system. Welcome to Beyond the Stars. Something big enough to warp their paths but invisible to our eyes. Brown and his colleague Dr. Konstantin Batygin ran the numbers on 17 of these objects. The math was brutal and unforgiving. They calculated that the odds of all these orbits being random was just 0.6%. That's not a coincidence. That's evidence. Evidence pointing to a hidden planet silently circling our Sun on a massive, elongated orbit. They called it Planet 9. Now, you might be thinking, if it's in our solar system, why can't we just point a telescope at it and snap a picture? Great question. Here's why it's nearly impossible. Planets don't generate their own light in the visible spectrum. They reflect sunlight. And the amount of light we can see drops off at an insane rate. We're talking about the 4th power of the distance from the Sun, not the usual square. By the time you get to where Planet 9 might be hiding, any reflected sunlight would be so dim it's practically invisible. The Zwicky Transient Facility tried. The Dark Energy Survey tried. Pan-STARRS 1 spent years hunting. All of them came up empty. Not a single candidate. Zero. Zip. Nothing. But here's where the story gets interesting. Enter Professor Tomo Goto and PhD student Terry Fan from Taiwan. These two had a different idea. Instead of looking for reflected light, what if they searched for the planet's own heat signature? Every planet we know emits infrared radiation, its own thermal glow. Even in the frozen depths of space, objects still radiate energy. They decided to dig through data from 2 infrared satellites, IRAS, which surveyed the sky back in 1983, and AKIRI, a Japanese satellite that did the same thing in 2006.
Now, IRAS was revolutionary for its time. Pulled to just 2.5 degrees above absolute zero, using superfluid helium, it detected 350,000 infrared sources that had never been seen before.
But combining these datasets was like searching for a specific grain of sand on a beach. We're talking about 2.4 million objects recorded across multiple decades. Terry Fan had to track each object's position individually, looking for something that moved in a way consistent with Planet 9's predicted orbit. They were hunting for something specific, a planet between 7 and 17 times Earth's mass, orbiting somewhere between 280 and 1,120 astronomical units from the Sun. Objects closer than 500 AU had already been searched, so Terry focused on the sweet spot between 500 and 700 AU. Here's the clever part. A planet on a highly elliptical orbit moves much slower when it's farthest from the Sun, meaning it would spend more time in that zone. More time equals better odds of detection. After filtering through millions of data points using the predicted motion models, Terry was left with just 13 candidates, 13 needles in a cosmic haystack. Then he went through each one by eye, scrutinizing every pixel, every measurement. And when the dust settled, only one remained. In the IRAS image, there are 7 pixels in the top left corner that are warmer than the background. 23 years later, the Akurari satellite captured the same region, and the warm spot had moved 47.5 arc minutes, roughly the width of 1.5 full moons. It had traveled exactly the distance and direction that Planet 9 should have moved in that time frame. Look, I'll be honest with you. If you showed me these images without context, I'd have no idea what I was looking at. The signal is faint, almost ghostly, but context is everything in science. This could genuinely be the first image we've ever captured of Planet 9. Professor Goto even joked that if it's confirmed, he might let Terry finish his PhD early. I'd say that's more than fair. Of course, not everyone is convinced yet. Mike Brown and Konstantin Batygin have raised some concerns about the orbital inclination being steeper than expected. But Terry isn't worried about waiting for confirmation, because the telescope that's going to settle this debate is already operational, the Vera Rubin Observatory. This beast of an instrument features the largest camera sensor ever created, 3.2 gigapixels. It can capture objects that are orders of magnitude thinner than anything previous surveys could detect. Scientists estimate it could increase the number of known objects in our solar system by a factor of 100. Its legacy survey of space and time program is generating 20 terabytes of data every single night, methodically scanning the sky for solar system objects. As Brown himself said, if someone handed him unlimited money to build a telescope specifically to find Planet 9, he'd probably just build the Vera Rubin Observatory again. In a few years, we'll know for certain whether Terry's candidate is the real deal. But what if it's not there? What if we search and find nothing? Well, scientists have some backup theories. Maybe there's no single planet at all, but instead a belt of smaller objects whose combined gravity creates the same effect. Or perhaps a passing star disturbed these orbits billions of years ago in a cosmic hit and run. Some researchers have even proposed we might have captured a primordial black hole the size of a football. And then there are the rebels, who think we need to rewrite Newton's laws of gravity entirely. Personally, I'm rooting for the planet. There's something poetic about the idea of our solar system having 9 planets again, especially for those of us who grew up memorizing Pluto before it got demoted. Plus, completing our map of the solar system feels like solving one of humanity's greatest puzzles. The Vera Rubin Observatory is searching right now as I'm speaking to you. Within the next few years, we're going to have an answer. Either we'll confirm one of the most significant planetary discoveries in modern astronomy, or we'll learn something equally fascinating about how our solar system works. If mysteries like this get your heart racing the way they do mine, make sure you're subscribed so you don't miss what comes next. We're living in the golden age of space exploration, and the edge of our solar system is about to give up its secrets.
The question is, are you ready to find out what's hiding in the dark?